This is the fifth and final video in this series. This tutorial should be used alongside our article, A Primer for Using Multilevel Models to Meta-Analyze Single-Case Design Data with A/B Phases, and that's published in the Journal of Applied Behavior Analysis. In the fourth video, I demonstrated how to use and install the MetaSem package and how to run a basic multi-level model in the statistical software program called R. Please refer to that first if you have not already done so, because it provides a lot of the context to run the model. In this video, I will add a moderator to the model. Now recall that in video 4, when we ran the basic multi-level model, there was significant variability across individuals, so that was at level 2 of our 3-level model. Knowing that there's that significant variability across either level 2 or 3, across individuals or studies, is really good information, but it's not that useful unless we have some way to figure out what the source of that variability is. So essentially, that variability is saying that the effect size is not the same for everyone, and we want to be able to figure out what are those things that make the effect size bigger or smaller for certain people or for certain studies. And so moderators are things that can impact intervention effectiveness, and we can test them to see if those are the source of variability. This is the R platform. If you didn't already follow along with the fourth video in this series, and you're just jumping in to this moderation, you'll have to make sure that you install the MetaSem package. So this line of code right here, install.packages, parentheses, quotation mark, MetaSem. We'll install the packages. And then you have to activate the packages by typing in the code here, library, parentheses, MetaSem, and that will open the package up for you. You also need to read your data file in. So that's what this line of code is right here. The generic code for multi-level models with moderators is very similar to the basic model. The main difference is that we'll add an X to the meta3 command. So first we need to give our model a name. I'm going to call mine S1 just for simplicity. S1 equals meta3X. And that X there tells the MetaSem program that we will be looking at moderators. The moderator I'm going to use is the target response type that was targeted for reduction in the intervention. We used DRL schedules as the intervention. We categorize the response type as either a socially significant response, so something like hand raising in a classroom, or as an arbitrary response, such as clicking a button on a computer. All right, so let's enter the code. We first have to tell R what the main outcome variable is, Y equals, and the main outcome is the G effect size, which we labeled as phase in our spreadsheet. We also need to tell it what the variance is, and that is called V phase from our spreadsheet. Then we tell it the cluster variable, which is the study, that clusters it by study. And then we can specify what the moderator is. So we call the moderator X, and we can specify whether the moderator occurs at level 2 or level 3. So level 2 moderator would vary across individuals within a study, whereas a level 3 moderator is the same across everybody in the study, but it varies across studies. And so target response type ended up only varying across studies, so it is a level 3 moderator, and we called that target in the spreadsheet. Then we tell R which data set to use, and so our data set was called SDRL. All right, and then you can hit enter. That runs the model, and then we do summary S1 to get the results. The output structure here is similar to what I showed in video 4, but what we're most interested in is the test of the moderator. This is shown as slope x3 underscore 1. So this second row of data from the table is the test of the moderation effect. And the result here is statistically significant, which means that the target response type does impact how effective the DRL schedule is. So based on this result, we need to find out a little bit more information about how the target response type impacts the effectiveness of the DRL. To figure this out, we can do a sensitivity analysis. Essentially, this just tests the effect of the DRL schedule separately for cases that have an arbitrary response and for cases that have a socially significant response. There is a way to filter those out through R, but to just avoid all that syntax, I just split my CSV file, my overall big data file that looks like this. I split it into two separate data files. So these two files here, which I labeled SDRL data target 0 and SDRL data target 1, those include only data that have target that's scored as a 0, which was the arbitrary response, and only data where target was scored as 1, which was the socially significant response. So I just took this big data file, found the target response, which is right here, and everything that was scored as a 1, I put it into the 1 spreadsheet, and everything that was scored as a 0, I put into the 0 spreadsheet. So all of the columns that corresponded to that, I moved them over. So I've already done that, and so now I have two different data files, and we need to read those data files into R. So I've read in these two data files. I labeled the data files as ST0, that stands for space responding target of 0, and space responding target of 1. I just pulled those two data sets in. And then all we have to do is run the basic multi-level model, the one without the moderators, the one we ran in video 4, separately for each of these two data sets. So I'll enter the very basic code for this model. We'll name the model S0. That was my terminology for the very basic model, but you can make it whatever you want. S0, and then just specify that I'm doing target of 0. So S0 T0 equals meta 3, no X for this one because it's just a basic model. Y equals phase, V equals V phase, cluster equals study, and data equals ST0. That's what I just called my data file for target equals 0. And I can hit enter. And I'll just copy and paste this so that I can make my target 1. So I'm just going to change the 0 after the T to 1, change my data to ST1, and hit enter. So now I've run both of the models, both for just target responses that are arbitrary and just target responses that are applied or socially significant. So then I'll type in summary S0 T0 to get the results of the arbitrary target responses. And here's the result of that analysis. The intercept is our primary result. This tells us the average effect across all of those cases that had an arbitrary response, that there was about a 10 standard deviation change, and that is a statistically significant reduction in behavior for the arbitrary response cases. You can also pull up the S0T1 results. These are the results for cases that had a socially significant response as the target response. And like with the arbitrary response, we want to look at the row labeled intercept. That tells us the primary effect. And because this is a moderation effect, or we're doing a sensitivity analysis for the moderation effect, we really want to compare this line for the socially significant response to the same line for the arbitrary response. So we already went over that, but it's -10, and it's significant. For the socially significant response, it is still significant value, but it is much smaller, only a -3. So the socially significant responses are reduced less than the arbitrary responses are using the spaced responding DRL. A nice way to display these data is to construct a forest plot. This plot shows the average effect as the center data point, and then the confidence intervals are the error bars. And this is just a nice way to visualize the moderation effect. On the bottom here, I have the overall effect. This is regardless of target response type, so combining both arbitrary and socially significant responses. And then the top two show the effect separately for an arbitrary response and a socially significant response. And it's just a nice way to really visualize that moderation effect. Everything I showed you in these past 5 videos can be replicated for the full session DRL. So just start over at video 1, but select the cases that are full session DRL and follow all the same steps. I'm not going to go through that step by step, but I do want to just show you the main result just for fun. This is the forest plot comparison for the full session DRL and the spaced responding DRL with the moderator of the target response type. And so the results are very similar. Not surprisingly, there's no statistical difference between the two types of DRLs. So that's it. You can find all of the data and the article on the Java website that go along with these video tutorials, and I hope that this was helpful.